Hi and welcome to the fourth part of this tutorial on C# events. This video is also part of a tutorial that serves as the fourth part of an advanced C# course. In this video, we'll focus on the observer design pattern. This is a very powerful design pattern and is suitable for any scenario that requires push-based notifications. The implementation of the observer design pattern entails subscribers registering to receive notifications from a provider. Push notifications simply means that the notifications are pushed from a central point to the relevant subscribers. The source of the push notifications is known as the provider, also known as the observable. Observers register with the provider, in other words, subscribe to the provider, and whenever a predefined condition, event, or state change occurs, one of the observer's methods is called by the provider. In this method call, the provider can also provide current state information to observers. So note that the observable can also be referred to as the provider, and observers can also be referred to as subscribers. So I'll be using these terms interchangeably throughout this tutorial. For more content like this on advanced C# concepts and much more, please consider subscribing and please ring the bell so that you'll be notified of future releases from this channel. In .NET, the implementation of the observer design pattern can be achieved when the subscribers class or observers implement the generic system.iObserver generic interface and the provider class implements the system.observable generic interface. The generic type represented here with the capital T represents the type, which can be a user-defined type that encapsulates the notification information communicated from the provider to its subscribers through push notifications. So the generic type, represented by the capital letter T in the interface definitions of both the provider class and the subscriber classes, is key to how loose coupling between provider and subscribers can be facilitated while still enabling rich and extensible data to be pushed from providers to subscribers. The system.iObservable and system.iObserver built-in .NET generic interfaces enable this pattern to be reused for multiple scenarios. The generic type represented by the capital T allows for user-defined types to serve as communication vehicles that can be extended without breaking the design of the relevant application. So let's look at a quasi-real-world example that can be used to explain the observer design pattern and give us an idea of when it is appropriate to use this design pattern. So we'll have to use our imaginations a bit to picture this example. Let's say a particular company owns a building with an automated security system. One of the functions of this security system is to identify external visitors arriving at the building, for example, to have a business meeting with one of the employees that work inside the building. So the process first involves the external visitor registering to visit the relevant employee on a particular day. Let's say that before an external visitor arrives at the building for the relevant visit, the external visitor must first register and during the registration process provide a clear photograph of the external visitor's face as part of the registration process. So when the external visitor arrives on the day of the visit and attempts to enter the building, a camera first scans the external visitor's face and subsequently sends the relevant pictorial facial information to a system whereby biometric artificial intelligence algorithms are applied to ascertain whether this particular visit can be authenticated, i.e., has this person registered, and if so, can this person be verified as the person claims to be? So this is essentially an automated authentication process. Once the relevant visitor has been identified, the visitor is automatically given access to the building. This triggers notifications to be sent to the building's security team and any internal staff members, i.e. employees of the company that owns the relevant building, who have subscribed to receive notifications regarding the relevant actions of the external visitors. The information that is sent to the subscribers, i.e. the notification data sent from the provider, contains information about the relevant external visitor and the time the relevant external visitor gained access to the building and then subsequently, once the visit is completed, a notification is sent when the external visitor exits the building. Another notification will be sent to all subscribers from the provider when a predefined time is reached and all external visitors have exited the building. For example, the predefined time could be 6 p.m., which has been deemed the end of the working day for the relevant company. The rule could be that after this time, no external visitors can gain access to the relevant building. In this example, we'll refer to this time as the cutoff time. Okay, so as I've said, we need to use our imaginations a bit here because we are going to implement code for the scenario just described within a console app.NET Core framework. In other words, the code will be highly simplified so that we can focus on understanding the observer design pattern. So the provider in this example will be the security surveillance system used to identify external visitors that have registered to visit a member of staff within the relevant building on a particular day. This example will contain two types of subscribers. One of the types of subscribers that we will create will represent the security team. They must be notified of all significant movements of external visitors, for example, entering and exiting the building. The other type of subscriber will represent any individual internal staff member who has subscribed to receive relevant notifications regarding external visitors. This employee would subscribe because a visitor must have a point of contact inside the building in order to successfully register as an external visitor. When the external visitor is authenticated on the day of the visit, a notification will be sent to the security team as well as any employee who is registered as the point of contact for the relevant external visitor. Okay, let's look at an overview of the main classes that will be created for this example. So here is a class that represents the observable. This class will represent a central place where surveillance data is processed. We'll create two classes that represent two types of observer. The first class represents an employee, i.e. a person that works inside the relevant building, who wants to be notified when a particular external visitor enters the building. This class is named Employee Notify. The second class represents the security team, who must be notified when any external visitor enters or exits the relevant building. This class is named Security Notify. We have a class here named External Visitor, which represents an outside visitor to the relevant building. This class serves as the generic type argument to both the iObservable generic interface implemented by the Observable class, as well as the generic argument to the iObserver generic interface, which is implemented by the observer classes. So this class allows data about the external visitor to be communicated from the observable object to its observer objects when the relevant notifications are sent. We have an iEmployee interface and an employee class that implements the iEmployee interface. The employee class provides a way to store details about an employee who works inside the relevant building. This class represents the employee details of a person who serves as a point of contact for an external visitor. An employee object is passed into the constructor of the Employee Notify class during the instantiation of an object derived from the Employee Notify class. So in summary, here are our main classes: Employee Notify, an observer class; Security Notify, an observer class; Security Surveillance Hub, the observable class; iEmployee, an interface defining an internal staff member record; Employee, a class that implements the iEmployee interface, so it represents an employee record; External Visitor, a class representing the person that has registered to visit a member of staff that works inside the relevant building. This class represents a person that must be authenticated on the day of the relevant visit. Let's look at the class that will serve as our observable class. We'll name this class Security Surveillance Hub. This class represents a central location where surveillance system information is processed and will be responsible for notifying subscribers with the relevant information about an external visitor. So notifications will be sent to the relevant observers when an external visitor enters the building, and another notification will be sent to the relevant observers when an external visitor exits the building. Firstly, let's answer the question, how can we implement a class so that it can be instantiated as an observable object? The answer to that question is that a class that will be instantiated as an observable object must implement the iObservable generic interface. The iObservable generic interface is a built-in .NET interface that is a member of the system namespace. The next question is what makes the observable interface a generic interface? The iObservable interface is generic because the calling code is able to pass a type as a generic argument to a class that implements the iObservable generic interface. In our example, the type that we'll pass as the relevant generic type argument will be a user-defined type named external visitor. As you may have guessed, this class will represent an external visitor. We'll discuss the external visitor class in more detail a bit later. The iObservable generic interface contains one method definition. This method definition is for a method named subscribe. The subscribe method contains one parameter of a type that implements the iObserver generic interface. So this parameter is defined as an observer type. We'll discuss the iObserver generic interface a little bit later. So the subscribe method must be implemented by the type that implements the iObservable generic interface. The implementation of the subscribe method must contain functionality that is executed when an observer subscribes to receive notifications from the relevant observable object. So we've now looked at the essence of what we are trying to achieve here by implementing the observer design pattern. Let's get started and create the code example. Let's create a project based on the console app.NET Core project template. Let's name this project and solution Building Surveillance System Application. So for our first class, let's create a class that represents the external visitor. This class represents the information about an external visitor that will be sent to the relevant subscribers when an external visitor enters the building and subsequently exits the building once the external visitor completes the external visitor's visit. So let's create a public class and name it external visitor. Let's create the properties for the external visitor class. So let's create a property for ID defined as int, first name defined as string, last name defined as string, company name defined as string, job title defined as string, entry date time defined as date time. This property will store the date and time of when the relevant external visitor entered the building. Exit date time defined as date time. This property will store the date and time of when the relevant external visitor exited the building. And lastly, an auto-implemented property named employee contact ID, and let's define this property as int. This property facilitates the storage of the ID of the internal employee, i.e. an employee who works within the building, responsible for being the point of contact for an external visitor on the relevant day of the external visitor's visit. Great, and that is our external visitor class. So let's create our observable class. Let's create a public class named Security Surveillance Hub. As explained earlier, this class serves as a metaphor for a central location where security-related information is processed. So, for example, an external visitor's face is scanned before gaining access to the building, and this pictorial information is subsequently sent to the Security Surveillance Hub, where the biometric information in the relevant image is compared against registered image information captured when the external visitor registered to visit the building. So if the two pieces of information match, the visitor is granted access to the building, which will trigger notification information about the external visitor to be sent to the relevant observers. So as discussed earlier, in order for this class to represent our observable, it must implement the iObservable generic interface. So let's write the code to do this, and let's pass in the external visitor type as our generic type argument. What makes the iObservable interface a generic interface? It is a generic interface because we are able to strongly type the iObservable interface. The capital T within less than and greater than symbols in the iObservable interface definition means that we are able to replace the T with our C# type. When this is done, it means we have strongly typed our generic interface. So let's strongly type the iObservable interface with our external visitor class like this. Generics allows us to stipulate a particular type for the relevant type placeholder at compile time. Note that a capital T is commonly used to represent the generic type placeholder. Generic functionality can also be accomplished through the use of the .NET system.object type. As we know, all types in C# ultimately inherit from the system.object type. So we are able to typecast a variable at runtime to any managed .NET type. The advantage of using generics for the same purpose is that we can achieve the same functionality, but this is done at compile time. This provides the advantage of compile time type checks, ensuring type safety, as well as results in greater performance for our code because we are able to omit the need for runtime typecasting. Typecasting, which is performed at runtime, also carries the risk of incurring runtime errors. Please don't worry if you didn't understand this brief explanation of why generics is significant. Generics will be discussed in detail in upcoming tutorials. So let's develop the Security Surveillance Hub class. So you can see that there is a red squiggly line under the iObservable text in the class definition. This is the C# compiler letting us know that we have not yet implemented code for the member definitions of the iObservable generic interface in the Security Surveillance Hub class. So let's hover our mouse pointers over the red squiggly line, click Show Potential Fixes, and click Implement Interface. As you can see, there is only one method definition in the iObservable interface that we must implement in the Security Surveillance Hub class. This method is named subscribe. Notice how the subscribe method definition contains a parameter of type iObserver, and the iObserver parameter type definition is automatically strongly typed with the type definition with which we have already strongly typed the iObservable interface. So we have strongly typed the iObservable interface with the external visitor type, and this has propagated to the subscribe method definition when we automatically generated the method definition that is contained in the iObservable generic interface, i.e. the subscribe method definition. This is a key concept to understand when understanding how we are able to use the iObservable and iObserver generic interfaces to implement the observer design pattern. The generic type gives us a means for creating a loose coupling between the observable component and the relevant observer components. The generic type, both defined in the iObservable and iObserver interfaces, allows the developer to strongly type these two interfaces with a common type. In this example, we are strongly typing these two interfaces with the external visitor user-defined type. This will become clearer as we develop this example application. Right, let's implement the code for the Security Surveillance Hub class. So let's create two member variables. Both of these member variables are of the generic list type. Let's define the first one and name it _external visitors. As the name suggests, this list will store a list of external visitors. When an external visitor gains access to the building, the external visitor is added to the _external visitors list. And you can see that we are strongly typing the _external visitors list with the external visitor user-defined type. Let's include a directive to the system.collections.generic namespace. The second generic list we need to define will store a list of observers. So this list will contain objects that are derived from the iObserver generic type that is strongly typed with the external visitor user-defined type. Let's name this generic list variable _observers. So when an observer subscribes to receive notifications from the observable, the relevant observer is added to the _observers list. Conversely, if an observer unsubscribes, the relevant observer is removed from the _observers list. So the subscribe method will be the last method that we will implement. As discussed, the subscribe method has to be implemented because it is a member of the iObservable generic interface, which the Security Surveillance Hub class implements. For now, let's create a public method that gets called when an external visitor gains access to the building. Let's name this method confirm external visitor enters building. This method's parameters contains relevant information associated with an external visitor, namely ID defined as int, first name defined as string, last name defined as string, company name defined as string, job title defined as string, entry date time defined as date time, and employee contact ID defined as int. Then we can write the functionality to instantiate an external visitor object and set the properties of the object we have derived from the external visitor user-defined type with the values that will be passed as arguments to the confirm external visitor enters building method. Then let's write the code to add the newly created external visitor object to the _external visitors list. As mentioned, the _observers list is populated with observers. Observers are, of course, objects that have subscribed to be notified when certain conditions are met, for example, an external visitor entering the building. So this method represents an external visitor entering the building. The visitor has been authenticated and is automatically given access to the building. So let's use our imaginations, and let's say that when an external visitor enters the building, the framework in which our observable exists invokes the confirm external visitor enters building method. The observable can now notify all subscribers of this event, as well as send the relevant data pertaining to the event to all the relevant subscribers. In this particular example, the relevant data is encapsulated with the external visitor object, which is derived from the external visitor class. Remember, the iObserver generic interface is strongly typed with the external visitor user-defined type, which makes it easy to send the data to the relevant observer objects. The relevant observer objects are stored within the _observers list. So in order to notify the relevant observers with the relevant data, we can write code to traverse the _observers list and call each observer object's onNext method. Note that when we call each observer object's onNext method, we are passing the relevant external visitor object as an argument to the onNext method. This is how each observer receives notification data whenever the relevant event occurs. In this example, the relevant event is an external visitor gaining access to the relevant building. So how does the observable, i.e. an object derived from the current class we are creating, know that an observer object implements a method named onNext? And even further to that, how does the relevant observable object know that the onNext method accepts an argument of type external visitor? This is at the heart of how the observer pattern works in C#. Each observer object is derived from a class that implements the iObserver generic interface. If we look at the definition for the iObserver interface, we see three method definitions, namely onNext, onError, and onCompleted. The onNext method contains a parameter of a generic type. So when we create an observer class a bit later, we'll strongly type the iObserver interface that our class must implement with the external visitor user-defined type. This action will mean that the onNext method will be strongly typed with the external visitor user-defined type. So the external visitor type becomes a common communication facility between the observable and the relevant observers. So the fact that we know that each observer implements the iObserver generic interface means we know that each observer object implements a method named onNext. The fact that the iObserver interface for each observer class is strongly typed with the external visitor user-defined type means that we know the type of the argument that needs to be passed into the onNext method. The iObserver generic interface contains a definition for a method named onError. This allows for the observable to notify relevant observer objects if an exception occurs, and also provides information about the exception through the built-in exception type. We are not going to implement custom functionality for the onError method in this example. Each observer object must, however, implement code for the onError method because the definition for the method is contained within the iObserver generic interface. The last method that we need to talk about is the Uncompleted method. So we will be implementing custom code for the Uncompleted method in this example. The Uncompleted method does not contain any parameters. The Uncompleted method notifies the observers that the observable has finished sending notifications. So this method should be called for each observer when a condition is met, whereby no more notifications need to be sent to the relevant observer objects. In this example, the Uncompleted method will be called on all observer objects within the _observers list when the relevant cutoff time has been reached on a particular day and all external visitors have exited the building. The cutoff time could be, for example, designated as 6 p.m. There may be external visitors who exceed this time constraint due to, for example, a meeting that goes on for longer than expected, or something of that nature. So two conditions need to be met for the Uncompleted method to be invoked. A certain time in the day is reached, for example 6 p.m., and all external visitors have exited the building. So next, let's implement a method that is called when an external visitor exits the building. So let's name this method confirm external visitor exits building. This method is a public method that contains two parameters. One parameter, which is a value that serves as a unique identifier for an external visitor. It is defined as the int data type. The other parameter is named exit date time, and as the name suggests, this parameter denotes the date and time when an external visitor exits the building. So firstly, let's write code to find the external visitor within the _external visitors list. If the external visitor is not null, i.e. the external visitor is found within the _external visitors list, let's write code to update the relevant external visitor object's exit date time property to the date and time when the external visitor exited the building. Let's then write code to traverse the _observers list and call each observer's onNext method, and pass an argument to the onNext method of the relevant external visitor object to notify the observers that a specific external visitor has exited the building. So let's create another public method that will be called when the cutoff time is reached. So by cutoff time, I mean this is a time after which external visitors are not allowed to enter the building. So we need to use our imaginations for some of these methods because we are basically saying that this method is called when certain conditions are met. In this case, when a certain time in the day is reached. Just like, for example, when the external visitor enters the building, the confirm external visitor enters building method is invoked. Or when the external visitor exits the building, the confirm external visitor exits building method is invoked. So let's create a public method that will be executed when the visitor cutoff time is reached. Let's name this method building entry cutoff time reached. So this method is called at a particular time, but we only want to call each observer's Uncompleted method if all external visitors have left the building. The fact that the Uncompleted method is called means that no further notifications will be sent from the observable object to the observer objects for a particular day. So we are going to use the link technology to check if any external visitor objects exist within the _external visitors list. But first I'm going to extend the external visitor class to include a property named inBuilding. This property is of type Boolean, and we can set this property according to the external visitor's current location. So we want to set the in-building property value to true when the confirm external visitor enters building method is invoked. Conversely, we want to set the in-building property value to false when the confirm external visitor exits building method is invoked. So we can now use the in-building property value to check if there are still external visitors left inside the building after the cutoff time has been reached. If you don't fully understand this code, don't worry, Link will be discussed in detail in upcoming tutorials as part of this C# advanced course. If the count of external visitor objects within the underscore external visitors list that have their in-building property value set to true is equal to 0, this means that the cutoff time has been reached and all external visitors have exited the building, so we can now call the Uncompleted method on all the observer objects that are currently in our underscore observers list. By calling the Uncompleted method on these observer objects, this is notifying the relevant observers that no further notifications will be sent. Okay, let's implement the subscribe method. So notice that the subscribe method contains a parameter of type IObservable, which is a generic interface. The implementation of the IObservable generic interface in this class, i.e. the Security Surveillance Hub class, is strongly typed with the external visitor user-defined type. So this is automatically propagated through to the subscribe method definition, where the IObserver generic interface is also strongly typed with the external visitor user-defined type. Note that when an observer object subscribes to the observable object, the observer object passes a reference to itself into the subscribe method. The this keyword can be used for the purpose of referencing an object derived from the class in which the this keyword is implemented. We'll implement this code when we create the observer classes in a bit. For now, let's implement the code for the subscribe method. And the code for this method is pretty simple. We first check if the observer object exists within the underscore observers collection. If the observer object does not exist within the underscore observers list, this means that a new observer object is subscribing. So we can write code here to add the observer object to the underscore observers list, which means that the relevant observer is now subscribed. The subsequent lines of code traverse all the external visitor objects within the underscore external visitors list and notifies the new observer object of the current information related to external visitors that exist within the underscore external visitors list. Now notice that the subscribe method returns a type that must implement the built-in IDisposable interface. So we are now going to create a class named Unsubscriber, and this class will implement the IDisposable interface. As the name suggests, the purpose of the Unsubscriber class is to provide a facility for the observer objects to unsubscribe to the observable object, i.e. to elect to no longer receive notifications from the relevant observable object. The Unsubscriber class implements the built-in IDisposable interface, which contains a definition for a method named dispose. When an observer object calls the dispose method, this action causes the relevant observer object to unsubscribe from the relevant observable object. So you can see that the subscribe method in the observable class, in this case the observable class is the class named Security Surveillance Hub, allows for an observer object to subscribe to the relevant observable object. The subscribe method returns a reference to the relevant unsubscriber object, which is derived from the class that we're about to create, i.e. the Unsubscriber class that implements the IDisposable interface. The observer object can simply call the dispose method, which is a member of the IDisposable interface, to unsubscribe to the relevant observable object. The built-in IDisposable interface is a member of the system namespace. Let's create the Unsubscriber class. As mentioned, the Unsubscriber class implements the IDisposable interface, which contains a method definition for a method named dispose. So let's create the class definition for the Unsubscriber class. Let's indicate that we wish to implement the iDisposable interface. Let's ensure that we are implementing all the members of the iDisposable interface. The iDisposable interface contains one member, a method named dispose. Let's create the constructor. You can see that this constructor contains two parameters. The first parameter is a list that contains observer objects. The second parameter is an observer object. So the functionality for this class is literally just to remove the passed-in observer object from the relevant observers list. So let's create two member variables. These member variables will be appropriately assigned the passed-in arguments to the constructor. Then the logic within the dispose method is simply to check if the relevant observer object exists within the relevant observers list. If it does, remove the relevant observer object from the observers list. The result of this action is that the relevant observer is unsubscribed from the relevant observable object and will therefore no longer receive notifications from the observable object. So let's go back to the subscribe method in the Security Surveillance Hub class, and let's return a new unsubscriber object derived from the user-defined type that we have just created. Note that the construction of the unsubscriber object entails passing a reference to the relevant observer and a list of all observers currently subscribed. Okay, so we have now written the code for the observable object. The class that defines the observable object is the Security Surveillance Hub class. So we can now create the classes that will represent our observer objects. We are going to create two classes which represent two types of observer objects. The first type we'll create is a class named Employee Notify. This class will represent an employee, a staff member that works in the building, that has been designated as the contact point for an external visitor. So this employee wants to know when the relevant external visitor has entered the building so that the employee can welcome the relevant external visitor at the entrance of the building. The second type or class will represent the security team, which must receive details of the external visitor when the external visitor enters the building and later exits the building. So let's first create code for the Employee Notify class. This class is an observer, so it must implement the generic iObserver interface. We also need to strongly type the iObserver generic interface with the external visitor type. So one way we can automatically generate the definitions for the members of the iObserver interface that we must implement is to hover our mouse pointers over the red squiggly line under the iObserver generic interface text within our class definition and click Show Potential Fixes and then click Implement Interface. And Visual Studio automatically generates default implementations for three methods. The method definitions for these three methods are members of the iObserver generic interface. The red squiggly line disappears because we now have implementations for the members contained in the iObserver generic interface. So in a bit, we'll implement more useful code for these methods. Before we create a constructor for this class, I want to create a definition for an employee record. Let's create an interface named iEmployee. We'll keep the employee record really simple. So let's create definitions for just four properties: ID as int, first name as string, last name as string, and job title as string. Let's create a class named Employee that implements the iEmployee interface. So let's go back to the Employee Notify class and create the constructor for this class. So when an object is created from the employee class, we want an employee object to be passed into the constructor of the Employee Notify class. So let's include a parameter of the iEmployee type within the constructor definition. We want to adhere to solid principles. The last letter in the solid acronym is Dependency Inversion principle, which states that classes should not depend on concrete implementations, but should only depend on abstractions. This is why the parameter within this constructor is defined with an interface type rather than a class. So we are defining this parameter of type iEmployee rather than of type employee. Very basically, SOLID is an acronym representing a set of principles that are design principles that can be followed in order for a programmer to develop software that is easy to maintain and extend. We'll discuss SOLID principles in detail in upcoming tutorials. SOLID principles serve as a foundation for object-oriented design patterns, like, for example, the observer design pattern. These design patterns can be implemented to solve problems that have been repeatedly identified in real-world scenarios. If you wish to read more about SOLID principles, please navigate to this URL. So let's create an appropriate member variable of the iEmployee type, and within our constructor, let's assign the passed-in value to the member variable we have just created. So let's implement our code logic for our onNext method. Notice that the parameter contained within this method is of type external visitor. When we automatically generated our default method implementations through Visual Studio, the fact that we had strongly typed the iObserver interface with the external visitor user-defined type propagated through to the onNext method. So the purpose of the onNext method is that it gets called by the observable object every time it is appropriate to send out notifications to the relevant observers. This is how the observable object is able to send out notifications to each of its subscribed observer objects, because the observable object knows that each observer object implements the onNext method. So the observable object traverses all of its observers and calls the onNext method on each of its observer objects to send out the relevant notifications. Each observer is able to handle the notification through its custom implementation of logic within its onNext method. So the code we are about to write gets called when the observable sends out its notifications. In this case, we want the designated employee contact to receive a notification when the relevant external visitor has gained access to the building. So let's write the logic for this method. Firstly, let's assign the passed-in argument of type external visitor to a local variable named external visitor. Let's create an if statement. The condition for the if statement checks the external visitor object's employee contact ID property value against the ID property value of the employee object reference that is passed into the constructor of this employee notify object. If these two values match, this means that the relevant employee is the registered point of contact for the external visitor referred to in this particular notification. So we want to maintain an up-to-date local list of external visitors for this employee notify observer object. So let's define a member variable named _external visitors as a generic list that can store external visitor objects. So let's write code to check if the external visitor object passed into the onNext method exists within the _external visitors list. We can do this by using link and checking if the ID of the external visitor object passed into the onNext method matches any of the external visitor object's ID properties currently stored within the _external visitors list. And we are assigning the result of the link expression to a local variable named external visitor list item. So let's write a nested if statement where the if condition checks if the external visitor list item variable value is null. If it is null, the external visitor object does not exist in our local list containing external visitor objects. So let's add this external visitor object to our list. Then the next line of code simply outputs a message to the relevant employee that the expected external visitor has entered the building, and we can also include the external visitor's details within the message. So if the else part of the nested if statement condition is true, the external visitor has already visited, and the notification must refer to the relevant external visitor exiting the building. So the logic simply updates the in-building property of the relevant external visitor object within the underscore external visitors list to false. The relevant external visitor list items exit datetime property is also appropriately updated with the relevant exit datetime property stored in the external visitor object passed in from the observable object to the onNext method of this object. So we have now implemented the logic for the onNext method of the employee notify observer class. So in the interests of time, we are not going to bother implementing code for the onError method. We'll simply retain the default implementation generated by Visual Studio in this example, but please note that this method provides a mechanism for observers to handle exceptions that may occur within the observable object. So now we must implement the logic for the onCompleted method. The purpose of this method is so that the observable object can notify the relevant observer objects when no further notifications need to be sent. In this example, there is a rule that the observer's onCompleted methods will be called from the observable object when a cutoff time is reached, for example, perhaps 6 p.m. on a workday, and all external visitors must have left the building. So a few external visitors may still be in the building past 6 p.m. For example, they may be in meetings that have gone on for longer than was first anticipated. The onCompleted method on all relevant observer objects will only be invoked from the observable object once all external visitors have left the building and the cutoff time has been reached. Let's say the cutoff time means that no further external visitors are allowed to gain entry into the building on a particular workday after a predefined cutoff time. So if these conditions are met, the observable can notify all observers through the observer's implementation of their onCompleted methods, and this means that no further notifications will be sent. At this point, the relevant observer objects will have a complete list of external visitor objects that visited the building during the course of the day. The external visitor objects will contain relevant information like, for example, certain details about the external visitors, as well as their entry and exit times to and from the building on the relevant day. So the observer at this point is able to create a final report relating to the external visitor data on a specific day. So let's implement the code for the onCompleted method in the employee notify class. Let's say that the relevant employee is only interested in the details of those external visitors that were there to visit the employee during the course of that day. So in the onNext method, we have only added the external visitors where the relevant employee was registered as the external visitor's contact in the building. So we can simply output the details of external visitors stored within the underscore external visitors list for the implementation of the onCompleted method. So let's first write an appropriate heading to the console screen. This heading will simply contain the employee name followed by the text Daily Visitors Report. Let's write code to traverse the underscore external visitors list. Let's set the in-building property to false, because if this method is being invoked, this means that all external visitors have left the building, and we want to keep our local copy of the underscore external visitors list up to date. Let's then write the details of each relevant external visitor to the console screen. This information serves as a final daily report for a specific employee and contains information about the external visitors that have visited the employee. So this is a report, and we want to space the columns for each of the outputted fields evenly. One way we can achieve this is by using the padWrite method, which is available on all string objects. The padWrite method accepts an integer value as an argument. So if, for example, we wish for the ID field to always occupy 6 character spaces, we can pass an argument of 6 to the padWrite method. So if, for example, the ID value only takes up 1 character space, the padWrite method will add the extra 5 character spaces, which will be empty spaces or white spaces, to the relevant field output. We can actually achieve the same effect when outputting variable values using an interpolated string, like this. So using the interpolated string technique, we can achieve the same thing and use less code. And that is the implementation for the Uncompleted method of the employee notify class. So we also want to include a method that performs the action of subscribing to the observable. In this case, as we know, the observable is represented by the Surveillance System Hub class. So let's create a method named subscribe that contains a parameter named provider, which is of the generic interface type iObservable, and is strongly typed with the external visitor user-defined type. And to subscribe, we can simply write provider.subscribe and pass a reference to the current object using the this keyword to the observable's subscribe method. But remember that the observable's subscribe method returns an object that implements the iDisposable interface. So let's create a member variable of type iDisposable. Let's name this member variable _cancellation. So now we can create a method named unsubscribe. The logic to unsubscribe the observer is simply _cancellation.dispose. So as mentioned, we also want to implement code for another type of observer class. So the class we'll create for this will be named security notify. And as the name suggests, this class denotes the security team that must receive a notification every time an external visitor enters the building, and a notification when the external visitor later exits the building. So let's include the iObserver generic interface that is strongly typed with the external visitor user-defined type within our security notify class definition. Let's auto-generate the methods that we must implement for the iObserver generic interface. So let's hover our mouse pointers over the red squiggly line, click Show Potential Fixes, and then click Implement Interface. So the first method we need to implement is the onNext method. The logic here simply checks if the external visitor object already exists within the _external visitors list. If it doesn't exist, we add the external visitor object passed into the onNext method to the _external visitors list. We then output notification text that is appropriate for the security-related observer to the console screen. So we can simply copy the implementation for the onCompleted method within the employee notify class to the onCompleted method within the security notify class and then manually change the heading to reflect that this is a daily report for the security team regarding external visitors. So let's finish off this class by implementing our subscribe and unsubscribe methods. So you may have noticed that we would actually be repeating the code for the subscribe and unsubscribe methods across our observer classes, namely the employee notify and security notify classes. So if we repeat the subscribe and unsubscribe implementations here, we are violating the principle of DRY, which is an acronym that stands for Don't Repeat Yourself. Here we would be clearly repeating ourselves. So let's refactor our code so that the subscribe and unsubscribe methods are reusable across our observer classes and are written in only one place. To centralize the functionality for these methods, let's create an abstract class named Observer. Let's make the Observer class implement the iObserver generic interface. Let's strongly type the interface with the external visitor class. So the rule here is that we must implement the members of the iObserver generic interface. In this case, however, we don't want to centralize the functionality for the onNext, onError, and onCompleted methods defined in the iObserver generic interface. We have different implementations for the onNext and onCompleted methods for our two different observer classes. So what we can do is we can create abstract method definitions for the relevant methods within our observer class. We can consolidate two member variables within this abstract class, i.e. the underscore cancellation member variable and the underscore external visitors member variable. The underscore cancellation member variable is of the iDisposable type and is used for unsubscribing an observer object. The underscore external visitors variable is of type generic list and is strongly typed with the external visitor type. The underscore visitors list maintains a central local storage facility for the relevant observer object of external visitor information. We can then centralize the functionality for the subscribe and unsubscribe methods so that these methods can be reused across both observer classes. As you may have guessed, the observer classes will inherit from this abstract class. So we can now change the class definitions for our observer classes, namely the employee notify class and the security notify class, to inherit from the observer abstract class. We then need to include the override keyword within the onNext, onError, and onCompleted methods within our employee notify and our security notify classes, which are of course classes that represent our observers. This is because we are no longer implementing the iObserver generic interface directly. We need to override the abstract method definitions for these methods that have been defined in the observer abstract class. So before we implement code in our main method and run the code, let's create a basic class that will help us differentiate between the text that will be outputted by our two observer classes, namely the employee notify class and the security notify class. So the obvious way that we can do this is by changing the color of the outputted text for each of these observer classes. So let's create a static class. Let's create a public enum and name it text output theme. Each list item value in this enum denotes an output theme. So let's name the first enum list item security. Let's name the second enum list item employee. Let's name the third enum list item normal. Let's add a method to the static class. Let's name this method change output theme. This method contains one parameter named TextOutputTheme and is defined as the enum we have just created, i.e. the enum named TextOutputTheme. Then the logic for the changeOutputTheme method simply evaluates through an if-else-if block the value passed into this method. So if the value passed into the changeOutputTheme method is the employee enum list item value, let's write code to change the background color to dark magenta and the color of the text to white. Else, if the value passed into the changeOutputTheme method is the security enum list item value, let's change the background color to dark blue and the color of the text to yellow. Else, let's reset the state of the text color and the background color back to their default colors. So let's go to the security notify class, and we can now change the color theme for the output text colors in the onNext method accordingly. And once the relevant text has been outputted, let's change the foreground and background colors back to their default values. And we can do this using our changeOutputTheme method like this. Let's go to the employee notify class and implement the same functionality, but of course change the color theme to the appropriate color theme we have defined for the employee notify output text. So now when we test our code, we will be able to differentiate between the output coming from an object derived from the employee notify class and the output coming from an object derived from the security notify class. Okay, so let's write some code in the main method to test our implementation of the observer design pattern. We have implemented code here for the purpose of understanding the observer design pattern, and to keep things simple and focused on the observer design pattern itself, we have used the console app.NET Core project template to create the infrastructure or framework to house our code logic. So before we write calling code in the main method to test our observer design pattern, it may be helpful to use our imaginations to picture a real-world representation of this example. So in the real world, we would have three types of entities. We have our two types of observers, namely an employee who works within the building and the building's security team. So the relevant observer employees, i.e. the employees who have subscribed to receive notifications when an external visitor enters or exits the building, may have apps running on a handheld device like tablets or smartphones that alert the employees when relevant external visitors enter or exit the building. The security team may have various personnel whose responsibility it is to monitor the entry and exit of external visitors. So the relevant security personnel may be notified through security-related software where one of its components is subscribed to receive notifications when an external visitor enters or exits the building. So the relevant security officer or officers may be sitting at a laptop or desktop monitoring the relevant notifications. Then we have the observable entity, which could be a server that resides on premises or in the cloud that is constantly receiving surveillance information from security cameras. It provides facial recognition functionality and assesses whether a registered external visitor can be authenticated and therefore enter the building. So in summary, the observers, i.e. employees within the building and a security team, are subscribed to the observable and receive notifications from the observable once a certain condition is met. In this case, the condition is an authenticated external visitor entering or exiting the building. With all this in mind, let's implement a few scenarios within our main method to test our implementation of the observer design pattern. So let's create an instance of our observable class. Let's create an instance of the observer class named employee notify and pass an employee object as an argument to the employee notify constructor. So we can imagine that Bob Jones is carrying a handheld device that receives a notification when an external visitor that has registered Bob Jones as the external visitor's point of contact arrives. Let's create another instance of the observer class employee notify and pass a new employee object as an argument to the employee notify constructor. So it's essentially the same scenario as before, but this time we can imagine that Dave Kendall is carrying a handheld device that receives a notification when an external visitor arrives that has registered Dave Kendall as the external visitor's point of contact. And these employees will also receive notifications once the relevant external visitor exits the building. Although they don't receive text output when the relevant external visitor exits the building, the notification is received and the relevant employee notify external visitors object list containing the relevant external visitor object is updated with relevant information, for example, the time the relevant external visitor exited the building. This information is relevant when the employee receives a report regarding external visitors, when the relevant cutoff time is reached, and all external visitors have exited the building. And let's create the other type of observer object, which is represented by the security notify class. This type represents a security team that must receive notifications whenever an external visitor enters the building and later exits the building. All observers will also receive a report once a cutoff time is reached and all external visitors have left the building. Remember, the cutoff time denotes a time after which no further external visitors are allowed to enter the building. So, for example, this cutoff time could be 6 p.m., which could be deemed as the end of the working day for the relevant company. So now we have 3 observer objects, which is comprised of 2 employees and the security team. And we have a provider, which can also be called the observable object, which is the central location where security-related data is processed. So let's subscribe all of our observer objects to receive notifications from the observable object. So when we call the subscribe method, we must also pass a reference to the observable object so we can call the confirm external visitor enters building method to simulate an external visitor entering the building. The arguments that we are passing to this method denote information about the external visitor, the time the external visitor enters the building, as well as the ID of the employee that serves as the contact point for the external visitor. So let's call the confirm external visitor enters building method to simulate the entry of an external visitor named Andrew Jackson and then an external visitor named Jane Davidson. Note that the last argument passed into the confirm external visitor enters building method denotes the ID of the employee whom the external visitors have registered as their point of contact. So the point of contact for Andrew Jackson is Bob Jones, and the point of contact for Jane Davidson is Dave Kendall. Let's then call a method to simulate these 2 external visitors exiting the building. We can do this by calling the confirm external visitor exits building method on the observable object. Once where the ID pertaining to the external visitor Andrew Jackson is passed into the method. We can then call the method again, but this time passing the ID of the external visitor Jane Davidson, signifying that Jane Davidson has exited the building. These 2 method calls to the confirm external visitor exits building method simulate these 2 external visitors exiting the building. So let's say that Andrew Jackson exited the building 2 hours after entering the building, and let's say that Jane Davidson exited the building 3 hours after entering the building. Lastly, let's call the building entry cutoff time reached method on the observable object, which denotes that the end of the working day has been reached. We have referred to this time as the cutoff time throughout this tutorial. If all external visitors have exited the building, a report of external visitors is sent out to all the subscribed observer objects. On a technical level, this is achieved through the observable object calling the Uncompleted method on all relevant observer objects. We have structured the code in the main method so that all external visitors have left the building before the cutoff time, so a full report should be sent to all observers. And this also means that no further notifications will be sent for that particular day. So let's run the code. Okay, so an error is flagged because the underscore observers variable is null, and we have tried to call its contains method. So I've realized I forgot to include a constructor for the security surveillance hub class, where we should have instantiated an appropriate generic list object and assigned it to the underscore observers member variable, as well as instantiate an appropriate generic list object and assign it to the underscore external visitors variable. So let's fix this issue and implement the appropriate constructor code for the security surveillance hub class. Let's try again. Let's run the code. Great. And if we look at our output, we can see that this is an expected result. Bob Jones, an employee, is notified when Andrew Jackson, an external visitor, enters the building. Dave Kendall, an employee, is notified when Jane Davidson, an external visitor, enters the building. The security team is notified when both external visitors have entered and exited the building. When the cutoff time is reached, an appropriate report is sent to the employee observer objects as well as the security observer object. The employee report contains information regarding external visitors where the employee served as the relevant external visitor's point of contact. The security observer object is notified of the relevant activities and relevant details of all external visitors for the relevant day through a report tailored for the security team. Great, so our observer design pattern has been implemented correctly and is therefore working as expected. Though I've noticed that the date-time output is not in the format I would prefer. I want to include whether the time is AM or PM. So we can do this by including TT within the date-time formatting string passed to the relevant toString methods. This is not ideal because notice that we are having to change this format in several places. In a professionally developed application, it would be good practice to configure this format in one place. For the purposes of this demonstration, we'll update the date-time string formatting in several places, but let's be cognizant that this is not the best way to implement this formatting functionality. Let's run the code again. Great! So let's simulate the scenario where the cutoff time is reached. So no further external visitors are allowed to enter the building past the cutoff time. But there are still external visitors in the building. So we can simulate this scenario by commenting out the line of code that simulates the external visitor Jane Davidson exiting the building. So in this particular case, Jane Davidson has not yet exited the building. Let's run the code. And the output reflects this. We see the correct output pertaining to the entry and exit of Andrew Jackson, but we only see an output for Jane Davidson entering the building and not exiting the building. This is an expected result. Note that we also do not see any of the reports outputted to the observers because these reports are only sent when the cutoff time is reached and all external visitors have exited the building. The code implementation for this is implemented in the building entry cutoff time reached method, contained within the observable class, i.e. the security surveillance hub class. In the building entry cutoff time reached method, the onCompleted methods of all relevant observer objects is called, but only if all external visitors have left the building. And if we include the method call to the confirm external visitor exits building method for Jane Davidson, but call the unsubscribe method on the employee notify object after this external visitor has entered the building, but before the building entry cutoff time reached method is called. So let's appropriately call the unsubscribe method on the observer object pertaining to the employee, Bob Jones. Let's run the code. And you can see that Bob receives a notification when his external visitor enters the building, but a report is not sent to Bob Jones when cutoff time is reached because he has unsubscribed before cutoff time is reached. This is because if an observer unsubscribes, the observer will not receive any further notifications after the observer has unsubscribed. On a technical level, when the observer unsubscribes, the code removes the observer from the observers list contained within the observable object, and therefore that observer is excluded from the list of observers that is traversed and sent notifications when certain predefined conditions are met. I hope you have enjoyed this video on the observer design pattern. This completes the final video in a video series on C# events and completes the fourth part of a course on advanced C#. So in this video series, we looked at the basics of events in C#. We demonstrated how we are able to subscribe to an event contained within another class, and how we can designate a method to handle the event. Event handling code in C# is implemented by using a delegate as an intermediary between the event and designated method that is called when the relevant event is raised. We demonstrated the use of raising events through code logic, i.e., when certain logical conditions are met in a class where the relevant event resides, the event can be raised in order to invoke the methods that have been designated to handle the relevant event. We demonstrated how when a calling client subscribes or unsubscribes to an event, that this functionality can be encapsulated within add and remove accesses, which are similar in nature to the use of get and set accesses for properties. We demonstrated how events can be raised through user actions, for example, a button click. We used the UWP Universal Windows Platform project framework as a foundation for this demonstration. We briefly touched on how the MVVM Model View View Model design pattern is used to loosely couple front-end functionality from business rules-related functionality when implementing code for a UWP project. In this regard, we also discussed the advantages of separating concerns, for example, to allow for cleaner code, to facilitate easier unit testing, to facilitate better maintainability of code, and to allow for separate teams to specialize in different aspects of a project, so relevant aspects of the project can evolve independently and without adversely affecting one another. Lastly, in this video, we demonstrated an example where the implementation of the observer design pattern was deemed as suitable because its core functionality involves pushing notifications out to multiple entities from a central point when certain conditions are met. Please consider subscribing for more content on advanced C# concepts like this and much more. And please ring the bell so that you can be notified when this channel releases new videos. If you feel you have gained value from viewing this video, please hit the like button. It will be greatly appreciated. Please feel free to share any of the videos released from this channel with anyone you feel may benefit from their content. And please feel free to provide feedback about this video in the comments section. As always, the code can be downloaded from GitHub. A link to the relevant GitHub repository has been included below in the description. Thank you and take care.